Alright, so now we have I3 is known and 0.5 IC equal 2 ampere is known. Now if we look at the other two loops, we're done of this loop. If we look at this loop, the voltages here are unknown. There's only this voltage that is known, so I would avoid this. Go here. Here this voltage is unknown and this voltage is unknown. I know only the current, so I would now go and look into our nodes. How many unknown is here? Before I go look into those four nodes, I notice where is the node, or I look at the node that has most current sources. For this node, it has this current source. For this node, none. For this node, 1. Node D shares one current source, two current source. So since I know this current, this is known, this is known, the only current is unknown is I1. You see how I can go ahead and start with the next step right away before I go and check for each node how many unknown are there. So always when you're taking nodes, go look how many current sources are there. If there's 2, then you're good, or at least look for 1 unknown. So here I would take KCL at node D. There's this current is leaving 5 ampere, so it's gonna be the negative. 0.5 IC, it's coming into node D, so it will be positive, and I1 also is coming in, so it's positive. So here you see KCL at D, 0.5 IC, positive, and then positive I1, negative 5. Positive I1, negative 5 equals 0. There's this one, I already knew it, 2 ampere plus I1 minus 5 equals 0. 2 minus 5 is negative 3, right? And then I move the number to the other side, so it's positive 3. So you can say this one would be I1 minus 3 equals 0, and then you move the 3 to the other side, so I1 equals 3 ampere. Now right away, when I know I1, I would go and find VR1. So I1 equal 3 ampere, VR1 equal 3 times 5, which is 15 volt. So I multiply 3 by 5, which is 15 volt. Okay, now we found VR1 I1. What do we do? I know the current here. I know the current here. I need to know. Now we already found those information in this resistor, I and V. We already found V and I, because if we look at the question again, determine the currents and voltages for each resistor. Now the only resistor we did not find its values is this one. Since I already found this current and I have this current, so at node A I only have one unknown, which is I2. I do the same way as I did for node D. I go ahead and find a KCL there. Now I'm standing here, I see this current is leaving, so it's a negative 0.5 IC. I see this current leaving, negative I1, and this current also leaving, so negative I2. So all are negative. Negative 0.5 IC, negative I1, negative I2 equals 0. Now 0.5 IC is 2 ampere. I1, I just found it, 3 ampere. So negative 2 minus 3, it's negative 5. Minus I2. Since I2 has a negative sign, move it to the other side to become a positive. So I moved it, I2 is negative 5 ampere. Now whenever you find I2, you can find VR2. VR2 equal I2 times 4 ohm. So minus 5 times 4 equal negative 20 volts. Okay, now let's look at the negative. Since the current is negative and the voltage is negative, that means this resistor is reversed. That means the positive should be to the right and the negative to the left, and the current should be the other way, since both are negative. So if you want to correct it, you can go ahead and say this is I, and I2 we already found it to be negative 5, so if I put it that way, it will be positive 5 ampere, and the voltage positive, negative, how many volt are 20 volt there. So this is 20 volts. Doesn't matter, because we know always that voltage is dropping at the resistor, so power is absorbed. Now, for part B, he asked for Vx. He said find Vx, right? Now, I found the voltage here. I found the voltage here, right? Because I know the voltages through those two resistors. And I know this voltage source. Can I find this voltage? Yes, by KVL, right? If you go and do KVL at loop 2, I'm leaving from positive VR1, negative VR2, negative 12, and then negative Vx. You go ahead and add all of these voltages. I already know VR1 to be 15, VR2 negative 20, we just found it here, VR1 we just found it previously here, VR1, and then minus 12 minus Vx, move Vx to the other side, so it has a positive sign, so Vx equal, you add all these numbers and then you have 23 volt. That's it for today, class. We would have another video about KVL and KCL, but this video would have none of the loops or the nodes has just one unknown. All of them would have two unknowns, so let's see how we're gonna deal with that. See you next time.